questions first before you can start the presentation.
Okay, hello guys, it's great to be here with you today. So I'm VisHeart606, my name is James, together with my colleagues Parisha and Jasmine, we are proud to present our idea called VisHeart. So what is the problem that we're trying to solve? So researchers, they want to create models or AIs to solve healthcare, they want to accelerate healthcare, right? So where do they collect this data? This data they're collected by cardiologists, doctors, radiologists. They draw the mask on the MRI images, correct? But the tools used for them, they're very, very complex. It's like giving Photoshop to them and just telling them, okay, this is how you want to label the data. But it's very complex. So that's where we step in. We want to simplify that process. And that's why we created VisHeart, where we simplify it to the extent of like maybe from Photoshop to your Instagram editor. So that's how simple it is. And what's more, it's all online, so it's easier. You don't have to download, install, or anything. So personally, we've witnessed how COVID-19 has affected friends, family members, where they get complications for cardiovascular diseases. And we realized that as students in AI major, we wanted to contribute in some way. So firstly, we are focusing on the segmentation of the heart, and then we can reconstruct the 3D model of the heart based on what the AI model has recreated, and we wanted it to be very simple. So you can see for number one, we start with an empty MRI image, we create the segmentations, and from there we can reconstruct the 3D mesh of the heart. So what's different from our alternatives? Alternatives are very complex, like what I said, it's like Photoshop, it's very complex to use. And what's different with ours is ours is very simple and straightforward. Alright, I'll pass the demo to Carissa.
Okay, so I'll briefly walk through the product demo that we have right now. So this is our website. User can just simply log into our website to view the dashboard with all the previously uploaded projects. So you can just upload any MRI scan. You can put description and project names to it. And you can preview the MRI scan images before you actually start the segmentation. So these are the MRI scan images. Then you click on the AI segmentation button to actually start the AI inference. So here's the results of the AI inference. When you can see there's different heart components segmented, you can visualize them across time and frame, and not just purely AI detection, but we actually offer manual editing as well, and manual inference if the users are not satisfied with the results. So we have brushing, eraser, is a basic editing. So apart from 2D segmentation, we actually also offer 4D reconstruction, meaning you can actually see the heartbeats across time. And this is a 4D reconstruction. So our target markets includes researchers, cardiologists, and radiologists, those professionals who needs AI-powered tool to guide them to actually to improve those cardiac care. So in Malaysia, there's actually over 21% of citizens aged 30 years old and above are at a high risk of cardiovascular disease. So we actually believe that there's a need for us to come up with a tool that can actually serve as a guideline to help them to improve the cardiac care. Yeah.
Thank you, Clarissa. My name is Jasmine, and I'll be continuing the slides from now on. So, what makes our product unique? Our product bridges the gap between AI models and real clinical usability. It's basically a web-based application integrating the state-of-the-art models, having interactive visualization and export features, as well as anonymized and secure data handling. And aside from that, we are also building this project using the MERN architecture, which is scalable and expandable in the future. So here's our timeline that spans from April to October. So from April to August, which is phase 1, we were building our 2D segmentation models. using YOLO V11 as well as Maxim. And from September to October, we moved towards 4D reconstruction of our cardiac component design, as well as finalizing our web-based application for deployment via AWS. To conclude this pitching session, James, Clarissa, and I, Jasmine, think we are developers that are being supervised by Dr. Miko, as well as our research partner, Ms. Katie Wong. So thank you very much, and together we can build a web-based application.
Oh, thank you so much to VisHeart606 for sharing the exciting solution. Yeah, over to you, Janice, for Q&A.
Last question.
Yes, please.
Okay, thank you very much here for the presentation. First of all, maybe if you can educate me again about the importance of these solutions, whether this is actually coming from the real demand from the doctors, why you started this project?
Okay, so data is currency. It's very important in the world nowadays, right? So you see, we've already passed the age of digitalization. There's a lot of data. But for this specific data image, and you draw a mask on it, it's very specific. It's not like created via social media or anything, specifically people to handcraft it. So the problem is that doctors, cardiologists, they're all very busy. They don't have time to go and learn how to use tools like Photoshop. So we create this tool to simplify it a lot easier, and we have AI to assist them to draw out like very simple one, and you can add on to it to fix the mistakes. So that's what we're trying to achieve, so that researchers have data to create models for their own.
Is this something that they requested, or they having difficulty, and why they need to do that?
Yes, because the data set is very little. There's very little data set surrounding all these cardiac masking images. So if you want more, you need to have people who want to do it. And when you want people to do it, they need the incentive to do it. So we make it simplified.
Okay, so I want to know like whether this is something that they really need, or this is something like additional tools that they can use. For example, for them to have a better, accurate diagnosis, or make it faster. So have you talked to them actually, the cardiologists?
Oh, I think this is specifically more for researchers rather than for cardiologists. The tool is for researchers to push to cardiologists. So like researchers, they want data. They can pay off cardiologists to go and create the data for them. But if it's too complicated, they wouldn't want to create this data, right? Like if I give Photoshop, help me do this, and I pay you. They wouldn't want it.
The point in the target market is cardiologists, so that's why. Yeah, maybe my suggestion to go to talk to the real cardiologists whether this is something that they require, and then what are the difficulties they're actually facing, and those difficulties are actually the one that you should focus on. So this is their demand, and this is where they want to pay.
Yeah, we have a question from Mr. Jacob. Alright, so awesome stuff, guys. But what's the benefit of being able to view my heart in 3D? Let's say if I can see my own heart in 3D, like from the MRI images, how does that benefit me?
Okay,
As a normal person, like, I'm not a cardiologist or anything, but I want to use your solution. How does it benefit like the normal person?
Or it's not for the normal user, it's only for those experts.
It's a very good question, but to visualize our heart using 3D is mainly for our end users such as researchers and cardiologists who actually want to see the actual heart of the patient. And for instance, if that patient actually have a diseased heart, it will be much more easier to diagnose things using both 3D and 2D segmentation.
Quick one also, because I'm quite interested in like files itself. Can they be 3D printed, and what is the export file that can be sending out?
Exporter file will be in GLB for 3D segmentation and NIFT for 2D segmentation.
well, we also support OBJ also. Yeah, OBJ and GLB.
We have a question from the
Thank you very much. I think apart from, I agree with my fellow judges here about what they did. Okay. So, if you were to push this to cardiologists, are they going to use it for pre-diagnosis, or the screening part, or to actually diagnose the patient?
It's more of an assistive tool rather than a diagnostic tool. So it's easier to visualize the 3D heart because most of them they can see it from the MRI scans already. They already have the expertise to do that. But maybe if you want to explain it to someone, like you want to explain it to somebody else, you can use it to show the 3D reconstruction. But I think most importantly, it's more for researchers to collect data.
Okay, and then within the visualization itself, is there any profession algorithm being deployed for you to view, because it's web browser, right?
Yes.
And compared to the real MRI data, which is quite large, so how do you handle that? Is there any profession being done?
Yes, so like we said just now, we were using OBJ, now we're using GLB.
Yeah.
GLB is a very compressed format already.
Correct.
Yeah,
And
so
how do you deal with the loss of or the simplification of the image?
GLB is lossless.
It's-
It's lossless, yeah. You don't lose any information.
Okay, sorry, just a quick one though. So to use this, you need to run an MRI scan first.
Correct.
Okay, just a suggestion. This is focusing on heart. In the future, any plan to go beyond heart, other parts of the body?
Yes, definitely for any other organ, yes.
I would suggest your knee, and you sell it to sports physio.
That's a very good idea.
Just
Yes.
suggestion, because I think they will make more money.
So we call it Disney.
Sell to football clubs, not in Malaysia, of course. Malaysia people have money.
Yeah, that's a great idea, yes.
Yeah, because physios will need that. Yeah, for an average person like me can use it as well. I just play this morning and I feel something in my knee. I want to check, is it completely torn or not for my ligament, for example. Just an idea for you.
I think that's a very good idea.
For future, but then again, one thing, MRI scan is very expensive. That's something that you want to look at as well. Value services, cheaper option for MRI scan maybe.
Maybe we could start working with like echocardiogram or something like that. Yeah.
Okay, thank you.
Alright, thank you very much.
Thank you. Sorry, you have time for a quick one? Just a bit off topic, but to detect, this is to detect defects and diseases, right?
No, it's for any kind of heart.
Any kind of
disease or normal, yes.
So if you still
Both
have to
works.
go for an MRI, first, we have to
Yes, currently we are working starting with MRI.
do MRI, then it can be processed.
Yes.
Okay.
Alright, and a round of applause to the team and VisHeart606. So